Is time travel really possible? Time travel has been a captivating subject in both science fiction and scientific speculation for centuries. From H.G. Wells' The Time Machine to blockbuster films like Back to the Future and Interstellar, the concept of traversing through time has sparked the imagination of countless individuals. But the tantalizing question remains, is time travel really possible? Could we ever leap forward into the future or journey back to the past, and what would that mean for our understanding of the universe, our reality, and even ourselves? This article will delve into the scientific theories surrounding time travel, examining whether it could ever be more than just a fantastical idea. From the complexities of relativity to the mysteries of quantum mechanics, we'll explore the possibilities, limitations, and potential consequences of bending the rules of time. By the end, you'll have a deeper understanding of whether time travel is something that could one day become a reality, or if it will always remain a dream of science fiction. The relativity of time, Einstein's revolutionary theory. To understand whether time travel is possible, we must first look at what science currently tells us about the nature of time itself. For over a century, Albert Einstein's theories of relativity have reshaped how we perceive time and space. His special theory of relativity, 1905, and general theory of relativity, 1915, offer insights into how time behaves, especially when objects move at very high speeds or are in the presence of massive gravitational fields. Special relativity and time dilation. Einstein's special theory of relativity proposes that time is not an absolute, unchanging entity. Instead, it is relative to the observer. This means that time can pass at different rates depending on your motion and the speed at which you are traveling. A phenomenon known as time dilation occurs when an object moves close to the speed of light. As an object approaches this limit, time for the object slows down relative to an outside observer. This means that if you could somehow travel at speeds approaching the speed of light, time would pass more slowly for you than it would for people on Earth. In a sense, this could allow for time travel into the future. If a person were to embark on a high-speed journey through space, perhaps traveling in a spaceship near the speed of light, they could return to Earth and find that much more time had passed for everyone else than for them. This kind of time travel, however, does not allow for going back in time, but it does suggest that moving forward in time, at least in a certain sense, is possible. General relativity and gravitational time dilation. Einstein's general theory of relativity introduces an even more profound aspect of time, the role of gravity. General relativity explains that massive objects like stars, planets, and black holes warp the fabric of space and time around them. This phenomenon, often described as space-time curvature, means that time moves more slowly in stronger gravitational fields. A famous example of this is the twin paradox, in which one twin stays on Earth, while the other twin journeys to a distant star at near light speeds and returns. Due to the time dilation effects experienced by the traveling twin, they would age much more slowly, and upon returning, find their sibling to be significantly older. This thought experiment demonstrates how time itself can be altered by both speed and gravity, offering a glimpse into the potential for time travel, albeit only in one direction. However, the idea of using gravity for time travel becomes even more intriguing when we examine the most extreme gravitational environments, such as black holes. The black hole paradox, a portal to the past? Black holes are among the most fascinating and mysterious objects in the universe. These massive regions of space-time are so dense that nothing, not even light, can escape their gravitational pull. According to general relativity, the core of a black hole, known as the singularity, is a point where space-time curvature becomes infinite, and the normal rules of physics break down. But could this be a gateway to time travel? In theory, a wormhole, a tunnel-like structure that connects two distant points in space-time, could form near a black hole. If such a wormhole could be stabilized and navigated, it might allow someone to travel back in time to the past or leap forward to the future. However, the practical challenges of wormholes are staggering. First, we don't know if wormholes even exist, let alone how to create or stabilize one. Additionally, the tidal forces near a black hole are so intense that any matter approaching the singularity would be shredded by gravitational forces long before it could pass through. Yet, the idea remains an exciting frontier in theoretical physics. Wormholes and the potential for time travel are consistent with some solutions to Einstein's equations, although there is still much we don't know about the behavior of space-time at extreme scales. Quantum mechanics, the strange world of particles. While relativity deals with large-scale phenomena like gravity and space-time, quantum mechanics governs the behavior of subatomic particles. At this microscopic level, the laws of physics become deeply counterintuitive, and time behaves in ways that defy our everyday understanding. Some quantum theories suggest that time, as we know it, might not even exist at a fundamental level. In the realm of quantum mechanics, particles can exist in multiple states at once. This is known as superposition and can even teleport between locations through quantum entanglement. These phenomena have led some theorists to wonder whether time travel could be achieved at the quantum level. Could particles travel backward in time? Could information be sent to the past? Some theories in quantum mechanics, such as the concept of closed time-like curves, CTCs, propose that under certain conditions, particles or information could travel backward in time. These CTCs are hypothetical paths through space-time that curve back on themselves, potentially allowing time loops where events could influence their own past. However, these ideas are still highly speculative and remain an area of active research. The role of quantum mechanics in time travel is further complicated by the many worlds interpretation, which suggests that every possible outcome of a quantum event actually occurs, each in its own separate universe. In this view, traveling backward in time might not change the past in the way we traditionally think of it, but could instead result in a parallel timeline or an alternate reality. Time travel paradoxes. The grandfather problem. While time travel to the future seems more plausible, traveling back in time introduces a host of paradoxes that challenge our understanding of causality. The most famous of these is the grandfather paradox. This paradox posits that if someone were to travel back in time and prevent their grandfather from meeting their grandmother, the time traveler would never be born, and therefore, could never go back in time to commit the act in the first place. This creates a logical inconsistency, a causal loop in which an event occurs because of itself, which seems impossible within the framework of classical physics. Several theories have been proposed to resolve this paradox, such as the idea that the universe might correct itself to prevent paradoxes from occurring, or the possibility that traveling back in time could create a branching timeline, where the past is altered in one reality but not in another. These paradoxes reveal just how difficult it is to reconcile time travel with the fundamental principles of logic and causality. If time travel were possible, it would not only require new physical theories, but it would also demand a rethinking of how we understand the flow of events in the universe. The ethics and consequences of time travel. If time travel were to become possible, it would raise profound ethical questions. What responsibilities would time travelers have? Could altering the past have unintended consequences, perhaps even catastrophic ones? What about the potential for exploitation or manipulation of history for personal gain? These concerns mirror some of the moral dilemmas explored in science fiction narratives, where time travelers face the consequences of meddling with the past. Moreover, time travel might create inequalities between those who have access to it and those who do not. What if only a select few could manipulate time? Could this create new forms of oppression or exploitation? The ethics of time travel could become as complex as the science behind it. Conclusion: the future of time travel. So, is time travel really possible? The answer is still uncertain. While Einstein's theories and the study of quantum mechanics suggest that time may not be as rigid and absolute as we once thought, the practicalities of bending the flow of time remain far beyond our current technological capabilities. Time travel to the future, in the sense of moving forward at a faster rate due to relativistic effects, seems within the realm of possibility, but time travel to the past is fraught with paradoxes and unresolved questions. For now, time travel remains a fascinating concept, explored more in the realm of theory and imagination than in reality. However, the continued advancements in physics, particularly in areas like quantum gravity, may one day lead to breakthroughs that make time travel a reality, though it's likely to be a very different kind of time travel than we've seen in the movies. As we look to the future, we must continue to ask ourselves not just if time travel is possible, but what it would mean for humanity if it were. Could we change history? Could we glimpse the future? And, most importantly, would we be ready for the consequences? Call to action: if you're fascinated by the mysteries of time and space, the best thing you can do is stay curious and continue learning. Explore the cutting-edge theories in physics, follow new scientific discoveries, and dive into the philosophical questions that time travel raises. Whether or not time travel is possible, it invites us to think deeply about our place in the universe and the nature of reality itself. Who knows, Maybe one day, you'll be the one to crack the code and discover how to unlock the secrets of time.